Hello, everyone. Thanks for finding the time to join today's Rapyd DevTalk, last one of the year. My name is Drew. I look after developer relations here at Rapyd. Rapyd, if you don't know, is a fintech as a service platform, an API-first company that pretty much allows anyone to build fintech applications on top of our full-scale API. Our speaker today is Kevlin Henney. Welcome, Kevlin. Kevlin is going to talk about not only 97 things every programmer should know, but spin it against some common languages or flavors of payments that the payment developers might use, such as .NET, Python, some other things. And I suspect he has a couple of other topics up his sleeve to talk about as well. So we'll have a talk for 30 minutes or so. There will be a Q&A at the end, so feel free to drop your questions in chat. And we can answer some on the fly along the way. Otherwise, at the end, there will be a Q&A session after the talk. So again, that said, welcome, Kevlin. We're excited to hear what you have to say and share today about how to live your best developer life.
Thank you very much for that introduction, Drew. Okay, folks, let's start with a bit of a screen share. Let's get that working. And just to reiterate something that Drew mentioned, as I'm going through things, discussing things, feel free to just pop something in the chat. I've got a chat window up that I kind of keep an eye on. So if there's something that you want to ask about that's in context, hopefully I'll catch sight of that and I'm happy to respond. Otherwise, we can leave other questions until the end. So, right, let's start with this book here, 97 Things Every Programmer Should Know. Well, that 97 is quite a lot, so we're not going to cover 97. We're just going to cover a few. I'm going to take a few items from this book, which I pulled together just over 10 years ago, and I have to say has aged very well. I still find myself referring to it and the ideas that people have described. And the important thing here is that I only acted as the editor. I led the project, but it's the different voices and points of view that you get that make this so kind of interesting. Because when you ask people, well, what are the things that you think people should know? They come from many different angles. Some people get very, very detailed in terms of the technology. Other people pull back and they look at the organization as a whole. Other people look at a very strong kind of testing aspect. Other people talk about code style. Other people talk about your tooling, and so on. There's kind of a wealth of possibilities in different angles. Now, of course, because I'm only going to cover a few, I'm not going to cover all of these various topics. I've tried to pull out a thread that makes sense here. I'll also refer to a couple of other books, but yeah, let's get to that. So this is what I look like when I'm standing up and actually giving a talk. So yeah, I still use my hands. I'm fairly easy to find online. Feel free to connect with me via social media. But this book here, I'm going to pull something to try and capture my kind of perspective on this. I pulled something from the preface that I wrote. There's an art, craft, and science to programming that extends far beyond the program. The act of programming marries the discrete world of computers with the fluid world of human affairs. And that, for me, is one of the most important observations. Certainly, many people who get into technology take it from a very technical perspective. They take it from the computer's perspective, which is a very kind of cut and dry world. But it turns out that when you actually hit the world, the greater challenge of software development is not simply that. Programmers mediate between the negotiated and uncertain truths of business and the crisp, uncompromising domain of bits, bytes, and higher constructed types. This is an important contrast. In other words, what makes software development both exciting and challenging is the fact that you have a foot in two very different worlds. The nature of these worlds is fundamentally different. When we talk about business, very little is certain. Businesses don't come with kind of simple error messages. It's not a matter of configuration. You may have convinced one colleague, but you haven't convinced another. One person from the business side has one perspective. Another person from the same business side has a different perspective. This, by the way, although I'm not going to get into it, is why you should always be cautious about the myth of the business. Whenever people say the business wants, it's very rarely true. Businesses are not people. Businesses are made of people. And the minute you have more than one person, you have more than one point of view. Hence, negotiated uncertain truths. The fact that one person may be utterly convinced that what the organization needs to go forward is a particular feature is not necessarily true for somebody else who has an equal saying and is outward facing as well. But then we hit the code and the world is very different. The world is filled with certainties. Most of our uncertainties are actually gaps in knowledge. They're not about negotiating the truth. They're about simply discovering the truth or holding basic misconceptions. There's no arguing with a compiler. If the compiler thinks your code doesn't compile, that's not a matter of opinion. That's not a matter of discussion. You can't hold a meeting to renegotiate that. That's not going to happen. So these two worlds have very different phenomenology. And in fact, given that I'm talking about 97 things every programmer should know, I should actually go back to where it started, which is the 97 things every software architect should know. So O'Reilly they started off this series with 97 things every software architect should know, which is effectively a standalone book. It was written by, or it's edited by Richard Monson-Hafel. It emerged out of Bruce Eccles' an online list that Bruce Eccles runs. Bruce Eccles known for books like Thinking in Java. And Richard had asked the group, he said, look, I'm doing a talk, 10 things every software architect should know. He'd submitted the title, but he said, well, what 10 things should I include? And all of us on the list kind of made loads of suggestions and said, you know what, there's a book in this. And that's kind of the origin story of that. And so I submitted a couple of pieces to this, and I'm going to start with one of those. Simplicity before generality, use before reuse. The reason I want to put this here at the beginning of everything is because one thing that sometimes attracts the developer mind and sometimes distracts the developer mind is, oh, let's generalize this. Let's create a framework. Let's make this, unfortunately, more complex than necessary. People are very easily attracted to generalization and future-proofing and all kinds of things like that. And and every now and then you hear people say, oh, we're trying to make it reusable. I run a lot of workshops. So I work for myself and I run a lot of workshops as well as doing consultancy and training. And one of the most common things when I ask people about, what makes code good or what makes an architecture good, people often say, oh, reusability. And I always push people on that to check, do they know what they mean? And often what we find is that people focus on reusability before they've actually focused on usability. They overgeneralize prematurely and end up with something that's far more complex and adds to the kind of the wealth of unmanaged technical debt that plagues many systems. So how do we create systems that are general? I'm not saying you abandon that, but as I've noted here, the best route to generality is through understanding known specific examples and focusing on their essence to find an essential common solution. In other words, make it real and then look around and see, well, what is there to be learned? Simplicity through experience rather than generality through guesswork. That is the basic guideline here. But let's go back to that kind of opening observation. Once we understand that we need to kind of temper our creative instincts, if you like, we still are left with the classic problem of what is it I'm trying to do here in the code? How do I communicate? Because that turns out to be one of the greatest challenges. The idea, I've met very few people who will openly acknowledge, although they do exist, even now, openly acknowledge that their job is just to instruct a computer. Oh yeah, I'm doing this, I'm feeding the production system. But actually, when you look at people's habits, they often think, oh yeah, that's my job, that's what I'm doing. And I'd like to offer a different perspective. In fact, I'm going to take this perspective from Dan North. Code in the language of the domain. This idea is that what we are trying to do is not merely instruct, a compiler to do our work for us. It's not a matter of instruction. That kind of view of computing is kind of like left way, way in the past. What we've discovered is that the greater problems are to do with growing complexity over time. Hence why I say simplicity is where we want to start. You've got to make it usable. Usable by whom? By your colleagues, by your future you, by people you're never going to meet. Software development, although we use the language of project management, it's often misplaced. Software development is mostly product management. Project management has very different priorities and it kind of distracts us. So if you ever get the chance to not use project management terminology, try thinking about product development. Projects have very different structures. Now, the reason that's important is because products have longevity. Projects have end dates. Okay, that's why I'm always amused when people say, oh yeah, I've been working on this project for 10 years. Well, that means it's either very, very late or it's not a project. It turns out they've been in lots of projects. It's a product that's been they've worked on for 10 years. And it's composed of many projects. But if you manage it like a project, then you will find that the code responds like that. It's structured in terms of short-term goals. Now, the point about this and the code and the language of the domain is the idea that you've got to take time to communicate. You've got to communicate to a future you. And the notion of domain-driven design is certainly not new. The terminology itself is nearly 20 years old. Eric Evans published a book, 2003, Domain-Driven Design. Domain-driven design community has progressively grown over the years, but the ideas are way, way older, and they go right back into the heart of a number of different movements, most notably perhaps object orientation. The idea that what we're trying to do is create an understanding and communicate it. And that understanding, it should not look like code. It should look like the concepts of the domain populated. And so let's have a look at an example that Dan actually includes here. So he's got this little fragment of code. If portfolio IDs by trader ID .get trader.get ID dot contains key portfolio.get ID. Okay, so this is Java. What we're doing is we're looking up in a map of maps. If you're not familiar with Java, basically it's a dictionary of dictionaries that we're looking up in. And we might look at this and go, I have no idea what's going on here. You know, but when we look at it, we realize that there's nothing wrong with the names. These names, there are no abbreviations here that are programmatic abbreviations. The only abbreviation here is ID, and that's a real world abbreviation. People use that as a real world abbreviation. So there's no programming abbreviations in this, and yet it's not clear what it's doing. We might be tempted to put in a comment, but, and we'll come to comments in a moment, we might be tempted to put in a comment, but actually, let's take a step back and say, well, wait a minute. This is what they're trying to say. Because this is actually, you know, if trader can view portfolio, this is actually to do with governance. The idea here is that we have not, although we've named the individual variables meaningfully, we haven't named the meaning of the composition. And that's what the extract method refactoring is for. Okay, that's really, it's just to say, hang on, this has a different, that we can make this more economical, we can make it more direct, we can communicate clearly. And we do that. All of that lookup of maps and maps, that's still there, but it's now hidden away. And this is an important thing. It's one of those things that people often overlook, is the small stuff to improve the meaning. We haven't actually changed anything about the code and its genuine control flow. We have simply moved and abstracted. To abstract is to remove something. And what we've allowed ourselves is the opportunity to be incredibly precise. Many people would have responded by putting a comment in here. So let's talk about one that I put in. Comment only what the code can say. Now, just as a point, a couple of these things, you may see a URL link on a couple of things. That's because these articles also exist. Certainly, I think almost all of my pieces, because the book was done under Creative Commons. All of my pieces I've actually put online at my blog, and I've also basically revisited them and extended them, because there's kind of a constraint on the original books. So I've got a copy of the 97 Things Every Software Architecture Know here. The constraints, basically everything fits 2 pages in the original form. And clearly there's a lot more that can be said on this. So I've expanded on a couple of mine, but also a couple of other people's. They put theirs up online as well. And this is kind of an important consideration. Comment only what the code cannot say. And this is an interesting one, because sometimes when people say, well, you know, I'm going to just comment my code, it's like, well, what is it you have to say? Why are you commenting your code? And sometimes people come at me and they say, well, I'm commenting my code because it's good practice. And I say, well, no, I've been doing this for a long time. You tell me what you think you're doing when you're commenting the code. I'm telling people what the code does. Well, what's wrong with the code that it doesn't say that? I'm telling people what this means. What's wrong with the code that it doesn't say that? Now, I'm not saying that you can say everything that you want in code, but if what you find your comments are doing is simply repeating what the code already says, then that's just not helping. That's just noise. Okay, very poor signal to noise ratio. If your code is if your comments are apologizing for the code, then guess what? You should be refactoring. That's what refactoring tools are for. Okay, we live in an era when refactoring tools are they exist and they are normal. So it's a little surprising to find that people don't know how and when to refactor, that we actually have legacy code, even though we have refactoring tools. This astonishes me on a regular basis. And that people will quite happily comment something rather than actually change the root cause of the comment. Most comments are apologies for the code, even if they're not consciously so. You know, this variable, a big explanation of what the variable is. Well, why isn't that the variable name? Okay. Why are we using other words? Why are we using a when we actually mean, what's the comment say? Altitude. Okay, why don't we call it altitude? In other words, my advice is not comment what the code doesn't say, it's comment what the code cannot say. In other words, imagine that you have no ability to comment your code. How would you write your code? Do it like that. And then anything left over that you still want to say and communicate, that's worth a comment. So, I've got a couple of questions coming up, which I will jump in here. So from Honey asks, suggest a few refactoring tools widely used for C, C++. C and C++ have not enjoyed the benefit of languages like Java and C#, for example. Java is probably the most mature in this space. There is a huge irony that the first language that was extensively researched for refactoring, and the earliest work on automated refactoring comes from Bill Opdyke in the late 1980s and was C++. These days you'd look at C-Lion, but you'd also look in the Eclipse environment for refactoring in those cases. And that's been getting better and better over time. I know when I first tried C++ refactoring tools over a decade ago, the result was disappointing and generally not repeatable, and did not always produce valid C++. These days, the story is quite different. But there's a lesson here before you refactor. Rajit Asapatu had this lovely point here about don't just dive in. So my concern is that people don't refactor, but there's another point here is that before you refactor, do actually consider refactoring as a design step. It's not actually a shortcut key. You can do refactoring. In fact, the most famous refactoring book by Martin Fowler was based on not having refactoring tools. In fact, some of my earliest talks on refactoring were, interesting enough, for C++, and I did not assume refactoring tools. Refactoring is not a tool-based thing, or rather, you need an editor. It is a discipline of design, and people often miss that. They think it's like a spell check or something like that, and it's like, no, it's more powerful than that, which is perhaps why people don't refactor. They don't realize that there's a design step here, but it is a deliberate step, as Rajit makes clear. So he says the best approach for restructuring starts by taking stock of your existing code base and the tests written against that code. Look at what's already there, understand why it's there. That doesn't mean that it's necessarily good, but understand its story. Understand the context in which you're going to try and change things. Also hold back. Refactoring is not rewriting. Rewriting is a different discipline. Refactoring may trigger an awareness that perhaps something needs to be rewritten, but refactoring is a stable approach through gradual transformation rather than big batch changes. It is the idea that it's always working. This idea that you are, as it were, walking rather than running. Running is an unstable configuration. When you run, you have 0 or 1 points of contact with the ground. When you are walking, you have 1 or 2 points of contact with the ground. It's a much more stable arrangement. Therefore, you're more likely to injure yourself or make a mess with running. Likewise with rewriting. With refactoring, the idea is you are walking. It's not a fast thing, but it is a sure thing. And remember that humans make mistakes. As Rajit says, restructuring will not always guarantee that new code will be better or even as good as the previous attempt. Understand that. I have seen and been part of several failed restructuring attempts. It wasn't pretty, but it was human. We're not perfect. It is a design move, and we may find that we have to revisit the stuff that we do. But that's not a reason to not refactor. It's just a reason to acknowledge this is that code has a life. Now, this idea of thinking and reasoning about things, as well as what to refactor, is elegantly approached by Bert Hufnagel. Put the mouse down and step away from the keyboard. Now, I love this piece for a number of reasons. One, the title. I think it's a great title. Two, the general advice. When you're stuck on something and you spent hours, you are stuck at the level, you are stuck at a particular level and mindset, a particular way of thinking. There's not a lot that you can do at that level. You've exhausted all the possibilities. And spending more time is not going to help you. You actually need to spend time doing something else. Take a step back, because clearly the mindset that you currently have is not yielding any benefits. You got to go and get yourself a different mindset, a more relaxed mindset. Go and get coffee, go for a walk, go to a meeting, watch some YouTube, whatever it is, do something that is different, that genuinely actually puts you into a different, takes you back from the task. And as it were, kind of releases the tension. You're being very problem focused, and maybe that's not helping you anymore. Sometimes it works out, sometimes it doesn't. But I also like the example that he gave, because it also highlights another aspect about code transformation. So this example is presented in Java, but that's not really important. What's important is this is quite messy. And importantly, this is the code. A couple of things to notice. One is that Burke shows there's a ... here. In other words, there's a lot more code like this. This is very procedural. It's very imperative. What is it doing? It's trying to parse a string that has a 12-hour, that contains a 12-hour time. But it is a brutal and long-winded approach to trying to extract the information, the hours, the minutes, the seconds, and whether we are ante or post meridian. But this is this is the code as it looked after it was refactored. This is the important thing. Refactoring is sometimes progressive changes. It's kind of like continuous improvement, Kaizen, as lean advocates refer to it. It's sometimes progressive and gradual, and sometimes that's all that you need, and that's just it. But sometimes you need to take a step back. So Burke took a step back from this code. He'd simplified it as far as he could at the level he was thinking. Came back to the next day. It's just like, wait a minute, hang on, why am I doing all of this? This is a pattern match. It's one line, it's declarative code. Even if you can't read regular expressions, I know sometimes regular expressions get a bad rap, but honestly, this is so much easier to read, even if you don't know regular expressions. The thing I sometimes talk about is explainability of the code. To explain this to somebody is quite tedious. It's very mechanical. Now, we want to raise the level of abstraction in our code, find the level at which we can be the most precise. I can explain this piece of code to somebody who doesn't code, just by reading from left to right. What we're expecting is a string. We'll start with a group that either has 0 followed by 1 to 9, or it's 1 followed by 0 to 2, followed by a colon. I can read it from left to right. This is a mess. And so the point here is that we've got a preservation of behavior. Sometimes our refactorings, our discoveries take a jump. In lean terminology, this is kaikaku rather than kaizen. How do we do this with confidence? Testing is the engineering rigor of software development, Neil Ford notes. This is a really important thing. Testing is cheap in software. In other disciplines, testing is an expensive, time-consuming activity. It's labor-intensive, it's logistically intensive. But in the world of software, everything's soft. This is informational. If somebody says, could you run that test again? You really don't have to do an awful lot. Whereas with physical engineering projects, to run the tests again is time consuming, financially involved, probably involves coordination across a number of people, and is not always something you can do at the drop of a hat. We should take advantage of the softness of software. Now, who do we write our tests for? Now, I talked about this in terms of the code before. We are trying to communicate. Writing code is an act of communication. It's an act of communication with a compiler. It's an act of communication with yourself. You're actually clarifying. And sometimes to clarify what we're thinking, we actually need to articulate that. But it's also a communication with your colleagues and the future. The reason I say this is because often testing ends up being a bit of a second-class citizen. Even when people are being test-focused, they end up thinking, oh, I'm writing my tests for the build system. And the tests, because they're not part of the production, they don't end up with the same quality. You're writing them so that the build system deals with them, as opposed to writing them for a person. So in other words, the title that Gerard chooses here is perfect. Write tests for people. I got him down to 2 pages for this. Gerard wrote this huge, great book on unit testing patterns. It's about 900 pages thick. There's some great stuff in there, but you can use it as a weapon. 2 pages, a little more direct. Who should you be writing the test for the person trying to understand your code, your production code. In other words, you're not writing tests for the people reading your test code. You're writing tests for the people reading your production code. Good tests act as documentation for the code they are testing. Now, I've got a question here from Phil. What is the best test strategy to test your code? Whoa, that's a surprisingly small question with an answer that I normally spend a few days answering, because there is no one best strategy. So I'm going to focus this one a little bit here by giving you a very simple example. I'll do this one in Python. You may be familiar with the Fizzbuzz problem. It's a common code encounter, an interview question. If you're not familiar with Fizzbuzz, it's a counting game. It's also a drinking game. You count 1, 2, 3. Well, you don't say 3, you say fizz. Any number divisible by 3 is replaced by fizz. 4, 5. You don't say 5, you say buzz. Any number divisible by 5 is buzz, followed by fizz. 7, 8. If I said 9, then I get it wrong. It should be fizz and I should have a drink. Okay, that's why it's a drinking game. And then when we hit 15, or other multiples of 3 and 5, I wasn't telling you the whole truth before. Multiples of 3 and 5 are Fizzbuzz. Okay, so this is not the world's hardest programming problem, except that it's a really good example of how to think about logic and so on. And I see so many pieces of code that don't get basic logical decision structures right. So yeah, Fizzbuzz at one level is a toy problem. But it turns out one of the most important things we learn in software is that large systems are built out of small pieces of code. If you can't write a small piece of code, why do you think you can write a large system? And this is one of the things that is constantly many developers struggle with. They don't see the relationship when they're taught small examples. They don't sit there and go, oh, now I understand, and I can use this concept as a building block to build large systems. They automatically assume, because of negative experience, build systems are necessarily messy and there's never anything small in them. That's only because they haven't been built well. Okay, I have seen systems that have been built in the way that I've described. They are so much easier to live inside. But let's just keep small. Fizzbuzz. Here's a piece of Python that does it. It's reasonably obvious and intuitive. It's not the hardest problem to solve, but here's the one that involves the simplest control flow and the least modifiable state. Actually, that's not strictly true. This involves really the least amount of state, but I don't think anybody's going to give you prizes for elegance. Well, no, it is elegant. It's just perhaps not comprehensible. The point is, whether you choose this approach or the slightly less friendly approach here, they should both pass the same test. So how do we test it? Well, you know, here's how a lot of people do it. Oh, I've got a Fizzbuzz function. I'm just going to have Fizzbuzz. I'm going to test Fizzbuzz. And I see this all over the place, but I have a method foo, I'm going to have a test foo, I've got a method bar, I'm going to test bar. And this is the most common. This is common, this is obvious, it's intuitive, it's widespread, and it's completely not the right way to do it. You need to break it down. Unfortunately, the way that many people break it down is they then start peeling out individual examples and, you know, oh, Fizzbuzz of 1 is, you know, test Fizzbuzz of 2, test Fizzbuzz of 3, test Fizz. You could be here for a long time, okay? We could be more explicit. Test that result for 1 is 1. That tells us more. That's good, because I'm now telling you what the result is that I'm expecting. Now we are beginning to move towards specification. Remember, we're actually communicating. This communicates nothing. Well, I say nothing. This communicates I am testing Fizzbuzz. I could probably tell that when I open the file. This communicates that there are a number of different cases, but they're not really special and we're giving them false significance. This now tells me what I'm expecting. Now we're beginning to specify, but we're not there. How would I actually specify this? Well, let's try this out in English. Every result, let's understand, this is a specification. Every result is Fizzbuzz, or a decimal number. Every decimal result corresponds to its input position. Every third result contains fizz. Every fifth result contains buzz. Every 15th result is Fizzbuzz. The input for every fizz is divisible by 3. For every buzz is divisible by 5. For every Fizzbuzz is divisible by 15. These are the 8 rules that completely characterize the domain. If I use PyTest, I can actually increase my coverage through parameterization. But more importantly, let's look at what we've got. I've just taken those terms and turned it into a set of tests. This is how you test Fizzbuzz. I very rarely see good Fizzbuzz tests. People normally have Fizzbuzz of 1 is 1 and stuff like that. This is a specification. You're now communicating to your reader, this is what we want. The goal of your test is not to simply to confirm that something works. The challenge that you want to meet with your test is that you tell people what you're expecting, what you mean by the phrase, it works. What does it mean for it to work? So in other words, that first test Fizzbuzz, doesn't tell me what it means. If you didn't know what Fizzbuzz was before, if you read the test, you wouldn't know now. But this, you're reading a specification. So let me just get a little more up to date. So last year, Trisha G and I finished editing 97 things every Java programmer should know. Now, if you're not a Java programmer, that's not a problem. I'm not just trying to sell books here. Half the advice in here is relevant to pretty much anything, but Java is the central focus in that sense. In other words, we're choosing an example, we're choosing something to chew on. And when I say Java, I mean the platform we use. We also talk Kotlin, Groovy, Clojure. But there was a really nice piece to make this point that was from Mariet van Dijk on using tests to develop better software faster. This was not unique to Java. It was not coupled to Java. But she had a number of really good points here. A failing test should tell you exactly what is wrong quickly, without having to spend a lot of time analyzing the failure. This means each test should test one thing. We should have cohesion. Cohesion is not just for classes and for methods. It's for tests as well. If you find your test is testing two different cases, then it's not really a test case. It's multiple test cases. Separate along those lines. Use meaningful descriptive names. Well, you see, that piece of advice is not particularly helpful if she had left it at that, but she doesn't. She tells us, don't just describe what the test does either. We can read. Tell us why. This is the intention. You're trying to communicate. And importantly, this can help us decide whether a test should be updated in line with change functionality, or whether an actual failure that should be fixed has been found. So for example, let's say I've made a change and I focused on the test that I'm aware of. I've made the change to the code and the test that I'm aware of, and I run everything, those pass, and then suddenly this test over here breaks. And I look at it and go, I forgot to account for this case. Okay, that tells me that the test needed updating. That was an oversight on my part. That's why the test failed. And I can tell that normally from the name, or I should be able to. That's the point, it's communication. Alternatively, I may be utterly surprised and go, well, that shouldn't break. Why is this broken? What assumption have we broken? What assumption? So there's something deeper and more problematic. In other words, is it a genuine bug that I found? So that's the kind of thing that the name should be telling us. But also another piece of advice, never trust a test you haven't seen fail. This, by the way, makes a very strong case for things like test-driven development, which follows a test-first cycle where normally the leading step is you write a test case for new functionality, and because that's new, it doesn't exist, and therefore it fails. So now you know at least your test is testing something. And now when you make it pass, you know that it's meaningful. So back to 97 things every Java programmer every programmer should know. The final item I'm going to cover and wrap up on a number of the other implications on the things we've looked at so far. There's a lovely piece by Nicholas Nielsen called Thinking in States. I find in many cases that many developers, they work with the abstractions and concepts and the paradigms of their languages, but they often don't use other modeling formalisms and other thinking formalisms outside that. So you may find somebody who is working in object orientation, and even on a good day, it's unlikely they're really using object orientation. They're probably using managers and anemic domain objects, DTOs. So a lot of what people call object orientation, I'm afraid, is not really what was intended by object orientation. So I can understand when people are frustrated with it. That's not what people are talking about. We do actually have a number of pieces, both in this one, both in the Java one and in the original programmer one, which actually say, if you thought, if you thought that object orientation was all of this manager stuff and controller classes, you're in for a big surprise. That's not what it's about at all. But even assuming that you are focused within the object paradigm talks about certain things, but it's not good on other things. In the functional paradigm, functions and transformations and that way of looking at code, that's also really helpful. It's more declarative. But again, that's not the only way to look at things. I showed you a regular expression example earlier on, which is neither functional nor object-oriented. You need to have more tools and points of view. And some of these come from the world of modeling. And state is one of the most neglected. Very few mainstream no mainstream programming languages have state transitions and modeling as a first-class paradigm. There are languages that do have that, but they are not what I would call mainstream. So many people overlook that the simplest description of their system can be thought of in terms of states, and then we use appropriate patterns and techniques to relate them into code. But as Nicholas says, in most real-world situations, people's relaxed attitude to state is not an issue. That's fine. Unfortunately, many programs are quite vague about state too, and that is a problem. So I'll close with an example. Let's imagine we have a queue. Okay, we've got a producer and a consumer. We have a queue, and queues typically should be finite, have a maximum capacity. And a queue can be filled up. It has a length. A queue is, by the way, it's a horizontal abstraction. So unless you're using the naming conventions that you find, so if I were in .NET, I'd be using count by default. If I wanted to have my class look like it belonged as a collection class in Java, I would use slightly different wording. I would use size. But if I'm not participating in those, or I have a free hand in the naming, then I recognize that it's a horizontal abstraction as opposed to something like a stack, which is a vertical abstraction. So it has a length. And we might say, yeah, okay, I see there's a state. It can be empty, it can be full. And it behaves differently when it's empty. You won't dequeue things. You can enqueue things, and you can't dequeue things when it's empty. And perhaps we could represent that by returning null or optional or something like that. And I could sketch up. Here's the life cycle. We're going to require that you cannot have no capacity. Your capacity must be greater than 0. We initially start off empty. When we dequeue and empty, remain empty. When we enqueue, we become non-empty, and so on. And this all seems to kind of work. It's not a very exciting state model. It's also not very complete. The real subtlety here is that when we're not empty, we can also be full and not full. And it behaves differently. When we fill something that is already full, then that's a failed enqueuing. We should get some kind of rejection. Okay, and depends, the appropriate style for that depends on the language that you're working in. If this were Java, then I'd say return an optional that has no value. If this were Python, I'd say return none would be a reasonable interpretation. Although sometimes Pythonists do like to throw exceptions, perhaps a little more than people in other languages, and so on. So the idea is find the convention that is appropriate for what happens when I try and enqueue on something that is full. But what I want to leave you with is the idea that this is not just simply a sketch to be lost in time, or you can use implant UML and version control it. I want to give you the idea that actually it helps structure our tests. So here I've written this in NUnit. I've obviously stripped out all of the relevant code because I want to focus on just the names. What I've got here is I have used hierarchical structuring. I have used namespace and class nesting to perfectly correspond one-to-one with the nested states that I had in my model. So the idea here is that my state model lives on in my description, my specification, as it were, of the code in terms of the tests, or my tests inform my understanding of the state, whichever one comes first. The idea is we're looking at it from multiple points of view. It gives us a richer mental model. It also fits in if you're familiar with the given, when, then approach to thinking about these things. Given a new queue, given an empty queue, when we dequeue, then it returns a default value. So there's a whole load of set of things that we can structure here, but it's the nesting and the correspondence here. It's a richer form of communication. And that is where I'm going to kind of end this with a quote from the American journalist Edward Murrow. And he wrote this many decades ago, and I'm surprised and delighted by its continued truth. I actually use this as the opening quote of the preface in 97 Things Every Programmer Should Know. The newest computer can merely compound at speed the oldest problem in the relations between human beings. And in the end, the communicator will be confronted with the old problem of what to say and how to say it. So thank you very much for those of you that are still here. I'm going to stop screen sharing. I'm going to answer Honey's question from earlier, which I did not, that she posted whilst just after I was talking about the idea of simplicity before generality and use before reuse. What's the trade-off between generality versus simplicity? Teams shouldn't also reinvent the wheel. Okay, now there's a number of different things here. So many of the things that are indeed very general are also quite simple. There is an expectation that in many people's minds, generality means more options, adding things. My experience suggests that most of the things that are more general actually have fewer pieces. They have fewer things. They tend to be simpler. I'm going to pick on this, which is a Pilot G2 pen. It's my favorite pen. I have lots of these. I have them in blue. I have them in red. They are surprisingly simple and they are profoundly reliable, and I can use them for a number of things. I also have more complex pens. I also, if you have kids or you have a good memory, when you're a kid, you could get much more complex pens. They normally failed and they never quite did the right thing. I had one of those kind of multicolored pens that you could check. You know what? This is way more general. Now, those are physical examples. When we look at a number of libraries in different programming languages, you can actually go through and see, well, some of the things that are trying too hard to be general really are trying too hard. There's so many options that are simply unusable or unused. And particularly where you're dealing with a language that doesn't allow you to have optional arguments or whatever, you find that just doing the simplest things is almost impossible. In other words, it's so general, it's almost unusable. And that I find is it's a fascinating paradox. So in that sense, I don't regard generality as a versus thing. I'm looking for the simplicity that keeps things general. Now that's actually quite hard. So let's be very clear. Most simple things are surprisingly hard to find. In other words, we've got to treat this as a search problem. I have an idea. Here's a piece of code. I come back to it a week later and I think, there's a simpler way of doing that. I also discover that not only is it simpler, but it's more stable. It has fewer dependencies, or it introduces one dependency that simplifies everything. In other words, there's that idea that in many cases, what we're doing is we're trying to find. This idea is design is a search, as opposed to design is a fixed result. So for me, I'm looking for something that is general within the space of what we know. Whenever we go outside that, then we often find ourselves guessing. And one of the hardest things to predict is the future. In fact, we're not even very good at predicting the past, as much revisionist history shows us. So there's this idea that, first of all, start with what you know. And then when you see 2 or 3 examples, it's just like, okay, I'm beginning to understand what's going on here. Or when you've sat with the code for more than a few weeks, you suddenly realize there's a different way of looking at this. How did I not see this before? And you end up with something that is both simple and general in many cases. Now, sometimes generality does involve adding things, and it will involve taking on complexity. But the idea is don't rush towards that. Let that arrive towards you rather than you rush towards it. So that's what I'm saying, is like, keep it simple enough that you're happy to throw it away and change your mind. And you may find that you've hit on something that's general, but you may also find that the complexity is necessary, and that's fine, but you now know it, whereas perhaps before you just suspected it. But there's also another point here. Teams shouldn't also reinvent the wheel. Okay, there is actually a piece in here on teams should reinvent the wheel often. Now, there's an interesting paradox here. What is it that we're trying to say? We don't, if a team sets out to say, we're going to reinvent, let's fork Node. Let's just reinvent a whole load of stuff. And it's just like, wait a minute, hang on. That's probably not where you want to go. Let's reinvent something that already exists and we are already dependent upon. Unless there are known problems with that and you are offering a known huge measurable advantage, then I'd say hold back from that. We don't really want to reinvent that. I do find in many cases the big challenge, it's a little bit like when we learn programming languages are small, even the big ones are small. Let me give you an example. I'm only pulling this out because it's the closest to hand. I have other language specifications. This is the C99 specification. Let's have a look. The C99 specification. It's a thick book, but actually, out of this thick book, this is the language specification. Let's look at page numbers. 200 pages of specification. That's tiny. And people go, oh my goodness, that's huge. No, that's tiny. Have you ever looked at the language specification for English or Chinese, or, oh, right, now I understand. Natural language is huge, it's messy, it's vast. But if you actually look at this, you will realize the core language finishes about halfway through. The rest is library. And C is not as well served by library as a number of modern languages. In a lot of modern languages, the library is vast. That's like picking up a dictionary. That's not a language manual. That's like, here's all the vocabulary, the hundreds and thousands of possible choices that you have. And that's one of the other challenges when we talk about reinventing the wheel. A lot of people are overwhelmed. They know one particular part of the library really well, but they're not so sure about the rest. I often find this just even in just doing simple hands-on exercises and running workshops, people are often unaware of some of the things that are available in their local library. And I'm also surprised by some of the things that people come up with, and I discover I'm not aware either. So I then dig around. One of the great things we have is the ability to find out this stuff. So the first thing is knowing that there's a wheel to be reinvented. But at the same time, there's another thing. And the reason that there is this piece in here about reinvent the wheel is sometimes you want to really understand what's going on, find something that is simple and build it yourself. Okay. In other words, know what is being done for you. So that's what the piece is trying to say, to understand what is it that library is doing for me. Now, the reason I say that this is a valuable thing is because pick the small stuff and go right back to where I started, the small stuff. We want to build big systems out of small things, whereas often we end up overcomplicating things and we build big things out of big things and we struggle with those. We want to learn what those small things are. We don't want to be constantly surprised. So in other words, learn how they are built. But this is, I'm going to say, I drive a car. I'm not very good on the mechanical side of a car, and I never pretend to be. But the level of knowledge that you can get by opening up in fact, my wife did a car maintenance course a few years ago. And she came back, it's just like, right, there's all this knowledge. She just knew so much more because let's find out how it's done. Now, it's not quite the same as building an engine, although she did actually buy a model, a scale model of an internal combustion engine that you could build and find out how that worked. In other words, let's put it together and find out how it works. One of my currently stalled lockdown projects that I'm going to get back to next year, because the weather was crappy this year, I plan to do it outside, is I play guitar, not particularly well. I'm going to build a guitar. That's what I'm going to do. Does the world need more guitars? No. Am I going to be a great luthier and builder? No. Am I going to learn a hell of a lot by understanding how it's built? Oh, you bet. I'm going to learn a new appreciation, and I might also learn a few tricks that I can take to these other things. So when we talk about reinventing the wheel, often that is what is intended by that, but it is not an invitation to, hey, let's just ignore all this other stuff that's already been done for us. Let's take advantage of other people's work, but let us also know what is actual work, and so therefore understands what it is that our dependencies are doing for us. Okay, so any other questions? Feel free. There's only a few of us here, so feel free to just unmute and ask. I'm happy to ask me anything. And I know that I wasn't able to fully answer Phil's question. One of the best strategies to test your code. There are so many. That's a small question with a very, very big answer.
Hi, Kevlin. Yeah, thanks very much for the answer. Yeah, regarding the reinventing the wheel, I think to me it's kind of a mindset, because in all the work experience and all, it is like in the company itself promotes reuse, and we have something kind of a repo where this coding, they call it coding bricks, they are stored. Yeah. So in every across the projects and teams, they promote coding bricks submission and usage. So it's been part of my work culture for a long time. But when it comes to this scaled agile projects and all, like we hear the term yakni, right? You are not gonna need it.
Yes.
So it's when we practice the other way for a long time, our brain is tuned to think like that. How we can reuse, or like how we can make it generalized. So that was my point.
Yeah, I think for a lot of these things, my experience has been it's never one or the other. It's normally both. It's a balancing act. It's like walking along a very okay. So it's like walking along a very high wall. You don't want to fall off one way or the other. It's a balance between the two. And there is this idea that sometimes people push reuse too hard. So a very good example of that, let's just travel back in time 5 years. There was the LeftPad incident, where an open source library was withdrawn from NPM, and for disagreements over licensing. Okay, and the guy who pulled his library was quite within his rights to do so. The big thing that people then discovered is that there were lots of sites that depended on this very particular piece. I mean, he had about 200 libraries in there. The one that people named the whole incident after LeftPad, it's 11 lines of JavaScript code. And it's not even, I mean, with all due respect, it's not great JavaScript. It's also not complex. It's to pad a string. And that's the point. It's just like, why have we introduced an external dependency to pad a string? That is exactly where we want to reinvent the wheel. If it's not, and JavaScript clearly now has the pad left function for a very good reason for this. But at that time, if I had been sitting there and gone like, oh, how do I pad a string? I know I'm going to look in NPM and see if somebody's written a function. Absolutely not. That's when you write your own code. That is when you reinvent the wheel. So the problem is that some companies have got to promoting dependency, or rather reuse, so much that they've ended up with dependencies they no longer understand. And there is this trade-off where this is the balance. It's a case of like, you know, for solving the hard problems, like let's get stuff out of a database or let's put things on a web page, I would take advantage of somebody else's work. But when it comes to let's strip spaces from a string or let's pad a string, I think I'm quite capable of that. That's elemental work. I don't want to draw in another dependency. And that's one of the things is dependency management is one of the other things. When we, and there's, so we have in here, there's one piece, don't repeat yourself. Okay, the dry principle. There's also another piece by Udi Dahan, beware the share. He cautions us to watch out for sharing code because sharing, you know, he's not saying don't do it. He's just saying, just be aware. And it goes back to Rajit's piece on before you refactor, the idea of being aware of the context, because the story that Udi tells here is that he came along, fresh graduate, filled with skill and ideas, and he saw two pieces of code in the code base and said, you know what, we can extract these and reuse them. And everybody then reviewed the codes. What have you done? Why have you done this? You've now taken two independent parts of the system that were evolving independently, and you've now made them codependent. You've introduced a dependency. Oh, right. People are not taught that that's a trade-off. And so therefore, that's why it's not easy, but that's the trade-off you're looking for. The trade-off you're looking for is like, if I introduce, so when people say reuse, the other phrase we should, because it sounds such a harmless term, the term we should use is introduce a dependency. If I introduce a dependency here, what is my benefit? In other words, let's find out that, and you used the word trade-off earlier. Let's also remember in English, trade-off, it's actually the right word for the idea. Is we often just are so used to it, we don't see that it's the right word. You're making a trade. Quite literally, you are saying, I would need to receive some benefit, and in exchange, I will offer you this. Okay, it's like any other trade, and a good trade is one where I get the thing that I want, and what I give is something I'm prepared and able to offer. A bad trade is one where I don't get what I want, but I'm still giving stuff away. In other words, oh, I've ended up with more dependencies. Have I achieved a real benefit here? Did I truly save time? No, probably not. So that for me is the balance. The reuse debate is a very interesting one, and there are a lot of different sides to it, but that's the question we need to be asking is reuse comes with a cost and it comes with a benefit, and you've got to look at that. You've got to look at, as it were, the mental spreadsheet. What are we getting for this? Or are we just putting, you know, one of the worst things you can end up with, Michael Stahl at Siemens in Germany, who I've known for years, he had this lovely way of putting it, which is sometimes with reuse, you just want one thing, and then you reach for the banana, but you get the whole gorilla. It's just, I want this thing here, but you get this whole massive dependency and extra stuff, you know. And these days, we need to be ultra cautious of that. Because when you bring a dependency and it brings its dependencies in, and there are security implications. We are still in the we're kind of still reeling from Log4j last week, the Log4Shell stuff last week. And so the point there is that I'm not saying anything good or bad about that, but I'm just basically saying is you've got to be aware of what you're pulling in. And sometimes people are not, and they're often surprised. So reuse is a trade-off like anything else in that sense. But yeah, it is that idea of like, I need to have enough knowledge that I can make a judgment call of like, yeah, this is absolutely where I'm going to use somebody else's library. And in other cases, it's just like, why are we doing this? It's actually easier for us to control the code, and therefore we understand this, rather than introducing an external dependency, which is potentially a liability and needs to be tracked. I'm happy to introduce it. If somebody says we need this middleware, absolutely, I don't want to reinvent that. But if somebody says we've got a small function here, it's just like, what's involved in me getting that right, and so that we own that, and the liability is within our reach. Okay, you can actually use a lot of financial reasoning and thinking to understand what we do with code. That's a very useful set of metaphors.
Thanks very much. Makes much sense.
Okay, I think we are at time.
Yeah, awesome. Thanks, Kevlin. I really appreciate it. Great conversation. Just a little thing to note here at the end. Jacqueline Frankish will be reaching out to you guys and asking you which book you would like, right? If you already have 97 Things Every Programmer Should Know, we're happy to get you 97 Things Every Java Programmer Should Know that Kevlin mentioned. There's just one thing for me to take away: comment only what the code cannot say. This was my biggest problem at WorldPay, probably, because I think there's some engineers throwing darts at my LinkedIn photo today for my excessive comments. So yeah, totally can take, that's my takeaway. But yeah, so just in closing, we're going to take this video, we're going to post it on our community.rapyd.net. It'll also be on the Rapyd Developer YouTube channel. Really, really appreciate you, Kevlin, taking the time and talking with us today. Also want to get the audience's point of view, so we're going to send you a short survey so we can get your feedback, so we can make sure that we're on target with what you guys are asking for in terms of content and developer tooling here at Rapyd. And we encourage you to connect on our community. Can't say it enough. Community.rapyd.net, and also be sure and look for our potentially January Dev Talk with Sam Newman, where we're going to obviously talk about microservices. And if you have any additional questions, you can contact us at community@rapyd.net. We're happy to provide any support, whether you're just looking for fintech knowledge, you're looking for Rapyd API integration support, or just want to talk in general. We're happy to chat with you. So thanks, everyone.